Welcome to Metric Maths Made Easy YouTube channel, presented by Tulani Major. Algebra, linear inequality equations. Yeah, we know what linear inequality equations are. Those are mathematical sentences that may be true or false depending on the value of x. So we're doing an example. Now, example says solve for x and represent your solution graphically. So you know, when you say solve for x, actually the actual question is, what is the value of x that will make negative 2x plus 3 less than 5, or which will make negative 9 less than or equals to negative 2x plus 3. So I'm going to solve this in two parts. So first I will take the negative 2x plus 3 and say equals to 5. Just to find the solution when these are equal. What you do is what you do on there, you add it, you separate. You must separate the 3 on the left hand side and separate the 3 on the right hand side. And then you end up with negative 2x equals to 2, positive 2. And then now you want to isolate the negative 2x, you divide by negative 2, and then you divide by negative 2. And then you get your value of x, negative and negative, we get a positive, equals to negative 1. And then now we say solution is x equals to negative 1. This solution is for negative 2x plus 3 equals to 5. Now what about this other side? Yeah, so if you take this other side, you say okay, negative 2x, which is unknown, plus 3, you write it on the left hand side, and then you say this is equals to negative 9. Also you're wanting to find the solution or the root of x of this equation. So do the same thing. You subtract the 3 because you want to isolate x, so you take 3 on the left hand side, you separate the 3 on the right hand side. Do that and then end up with a negative 2x equals to negative 9 plus 3 is 12. But because they are both negative, so it's negative 12. Now you want to isolate the x again, so we divide by negative 2, divide by negative 2. What you do on the left hand side, you do on the right hand side, divide by negative 2. So you end up with negative divided by negative, you end up with the x equals to a negative divided by negative, positive 6. So end up with x equals to 6. So now what we have is, I write it here also, so we've got a solution. X equals to 6 for this equation, negative 2x plus 3 equals to negative 9. So I'll leave this one here whilst I do the inequality. Now let me rewrite the inequality now. So negative 9 less than or equals to negative 2x plus 3 less than 5. So now we're doing both what I've done. So we've got a solution of x equals negative 1 and x equals to positive 6. Those are your roots, the solution when this negative 2x plus 3 equals to 5, or when this negative 2x plus 3 equals to negative 9. So now let's do like combined now. So what you do is, now we've got the middle, got the left, and then we've got the extreme right. So you started isolating x, you started by separating the 3. So whatever you do on the middle, you do on the other side, and then you do also on this side, so that the equation remains true. Yeah, so negative 9 minus 3 less than negative 2x plus 3 minus 3 less than 5 minus 3. So what you end up with here, you end up with negative 12 less than or equals to negative 2x less than 2. Yeah. So remember what we want to do, we want to isolate x. So we have to divide here by negative 2. So when you divide by negative 2, remember now we've got this inequality sign, yeah? Negative 2, we're dividing by a negative. Yeah? I explained that when you divide by a negative or multiply by a negative, the inequality sign changes. So, okay, let me write the answers first. So, negative 12 divided by negative 2 is a positive 6. And then negative, and then here, yeah, we're going to have an x, and there, negative 1. But I said, when you divide or multiply by a negative, the inequality sign changes. So this sign is changed now to greater than or equals to. Similarly, this one is going to change to greater than. But in mathematics, like even when we write from left to right. So like negative 1, you know, is less than 6. So I start with negative 1. Negative 1 is less than x. See, the sign now changes. X is greater than negative 1, x greater than negative 1, but now say negative 1 less than x, less than or equals to 6. X is less than or equal to 6, or 6 is greater than negative 1. So this is how the solution is written. But we have asked that we represent this thing graphically. Yeah? So you see, this negative 1 was the solution when x was when negative 2x plus 3 was 5, and then this 6 was the solution when negative 2x plus 3 was equals to 9. So to represent it graphically now, you know you've got your number line, yeah, your axis. So I've got two values, okay, not two, this I've got a 6 here, no, a 0, negative 1. Then I've got a positive 6, 3, 1, 2, 4, 5, 7, 1, 2. Yeah. This is your y equal to 0. So we say your solution is at x equals to negative 1. So there is your negative 1. And then also at 6, there is your 6. So we say your x is between negative 1 and 6. But your x is not equals to negative 1, but it is equals to 6. So this is how you represent it on the number line. You remember when I showed you how to represent the inequalities on a number line. This is how we do it. So this is your solution for this equation for solve and represent graphically. Yeah. So maths is easy, but you need to practice. You cannot just master it. Yeah. So please see if you can practice this and get the same answers. Maths is easy. Thank you and goodbye.